Hello everyone, welcome to the channel Statistica Hub. So in today's video, we're gonna continue our previous lecture that was on mean. Now in today's video, we will cover some topic regarding median. Okay, so in the previous video, we have checked out like we have various kind of central tendency, and out of those central tendency, we had read something about mean. Okay, and in the previous example, we have seen something like there was some error, like we try to find some value out of some data. Technically, we are having some data and we try to get some like representative value for this data. Okay, and then we use that value for our further studies or further results, conclusions, or any kind of research or something like that. Okay, so we find something like we can have some kind of error, like maybe the mean that we are getting, that mean may not be the mean that we are getting, may not be some meaningful. So meaningful mean to say, like in the previous example, that was the example of Kung Fu classes, we seen a mean like, okay, the mean was coming out to be like 38. But in the class, the majority of students are like 19, 20, 21, something like that. So technically this mean that we calculated in the previous lecture or the previous problem, we seen that this mean is somewhat absurd. Absurd mean to say meaningless. So in that case, we try to find some another kind of central tendency that can give us a value for this, like representative value for the data. Okay. So then we study about median. So what does median mean to say? So in some very basic format, I can say that like median may be something like, okay, if I have data like, okay, this is the data point, this is the data point, this is the data point, this is and so on, the data point coming out to be like this. Okay. If I arrange the data point in some ascending order, okay, in that format, if I go just by taking the central value or can say the middle value, then this middle value is technically known as median. Okay. So when our mean is becoming some absurd value, in that case we go for median so that we can like we have some data and we can make some appropriate decision regarding this data. We can get some appropriate or can say some representative value for the data, and that representative value in this particular case that will be median. Okay, so we know like how do you calculate the median. Okay, so median is technically the middle value. Okay, now let's come up to the example of Kung Fu classes. So in that particular example, we have seen something like, okay, the data was something like 19, 19, 20, 20, 20, 21, 21, and these two data for the masters, okay, or can say the coach. And due to these particular values, or can say these particular values were known as outliers. And we read about outliers or we studied about outliers in the previous lecture. Okay, now let's come up to the concept of median. So I just told you like median will be the central value. So we have like first value, second value, third value, fourth value, fifth value, sixth value, seventh, eighth, and ninth. Okay, so we have values like this. So in this particular case, if I go for like central value or the middle value, that means to say, okay, 1, 2, 3, 4, 1, 2, 3, 4. So technically the fifth value that will be taken as the median. Okay, so from here I can get the like the median equal to like can say the median will be 20 in this particular case. Okay, and now I know like for the classes for Kung Fu, we can see like only the teenager people are there in the class except the masters. So this 20 is technically a meaningful value or the appropriate value for this particular kind of data. Okay, so this was the initial understanding, like how do we need, why do we need median, and how do we calculate the median. Okay, so in this particular data format, I can see like we have only odd number of values. Okay, so what if we have even number of data points? Okay, so if I add up another value, say 90, 19, 20, 20, 20, and I say 21, 21, and 21, I added up another 21, 100, and 102. So now we are getting like 10 values. Okay, but now about the median. So I have to go like the central tendency, that is median. And the basic definition of median that says, okay, go to the middle value. Okay, so first value, second value, third value, fourth value, fourth value, fifth and sixth. Like the both two are on the central value. So in this particular case, we don't have we don't have unique median. Okay, what does that thing mean to say? So technically we have these two as the central values, but to define a particular median value, we need to get a result or can say some data. We need to define a particular value. For this case, every data point, or can say every value that is in between 20 and 21 will make our median. That means to say, for in general case, we take the median to be like the mean of these two numbers. Okay, so the median in this particular case, that will be like 20 plus 21 divided by 2. Okay, so in these particular two examples, we can see that the median can be a data point from the data. Okay, so in this particular case, the median equal to some data point. Okay, and this data point is coming out from the particular data that we have. Okay, in this particular case, we can see that the median can be a value that is not in the data. Okay, like if I get a value like, okay, I can say like 20.2, that is also a median, 20.3, that is also a median, and so on. And we can see like 20.2 is not a data. Okay, so like this is how we calculate the median. Okay, so we have a picture over here that states like how to find the median in 3 steps. So line up your data in order. That means to say ascending order. Okay, the first step states that just arrange the data in some ascending order so that I can compare the values. Okay, the first value, second value, third value, and so on. Okay, in some increasing order. If you have an odd number, okay, if we have an odd number, the median will be the middle value. That means to say if you have odd number, that means to say if I have n data points and n is odd, in that particular case, we go for the central value, the middle value, that will be placed at n plus 1th divided by 2 position. Okay, so the position for the median value in case of odd number of data points, that will be n plus 1 divided by 2th position value. Okay, so in case of the even number of data points, that means to say if our n is even, in that case we can define the median something like this. So adding the two middle values together and dividing by 2. Okay, so technically that will give us a median. And this particular format of median, this will be a particular, can say some unique median if I make the mean of these two values. And in general, if I go for like how many medians will be there, so there can be many number of medians possible. Okay, so every data point, or can say every point in between these two particular data points, if I say this and this, if they both are the central values, in that case every point in between these two values will be a median. Okay, so this was the basic concept of median, like how do we work out regarding a median value, how do we go for the median or something like that. Okay, now let's work out an example. So I will be having an example on the next page. We will try to work out on that example. We'll try to solve that example. Okay, okay, so we have like the data regarding this particular example is something like that. So your job is to play like you are the data. Okay, this is the data, and you need to play for the data and say what the median of the each set. Okay, so it is the set one and it is the set two, and we need to find the median for each of the set, and we need to find like whether the data is skewed or not, and what about the mean and median, like the relation between mean and median. So for this particular data I can see like this. Okay, so we can have the values like x can take, okay, x can take the value 1 2 3 4 5 6 7 and 8. Okay, and the particular frequencies are something like this. So before calculating the median, if I go for like skewness of the data, so technically if I make the values like, okay, this is the frequency and this is the x value. So for the 1, 2, so on, and the finally 8th value. So we have like frequency for 1 is to be 4, so it can be something over here. Then frequency for 2, that will be like 6, so that will be bigger. Then for 3, that will be 4 again, so that will be 4, 4, 3, 2, 1. So I can say like roughly if I make a curve, that curve will be coming out to be something like this. Okay. And from the previous lecture, we can see like, okay, this is a right tailed or can say right skewed data. Okay, so we calculate like the skewness of our data one. So the data one is right skewed data. Okay, and we know that for the right skewed data, the mean value will be on the right word value. So technically, we can find some mean value to be over here. So mean. Now let's calculate regarding the mean, sorry, the median. Okay, so we have four values over here. Okay, so one is repeated like four times. So if I arrange the data in this format, then one, 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 then I go for two, 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 and so on, six times and so on. So if four values for one, if I cancel out this, then this cancel out. Okay, for six, if I calculate this thing, then six, this, one left. Okay, and we have four values over here and one value over here. That means to say the median will be like 3. Okay, so that will be the median. So the median will be something over here. So that is median that equal to 3. And I don't calculate the mean. I can just see from the graph that the mean value will be on the right side, tending towards the right side. So technically, for a right skewed data, for a right skewed data, we can see that the median value is bigger than, sorry, is smaller than the mean value. Okay, like the median value is coming out to be 3 and mean value is something bigger than 3. So for a right skewed data, mean is bigger than median. We need to learn that thing. Okay. Similarly, we can go for example 2. For the example 2, I can see like, okay, 1, 1, 2, 3, 4, 4, 5, 6, 5, 5. Okay, so the graph will be something like this. Okay, 5, 5, 4, 4, and then 3, 2, 1. So I can see like, okay, the data is left skewed data. Okay, it's like simple observation from the graph. Okay, and for last two data, we know the mean value will be on the left side. So technically there will be some mean value. And if I calculate the median value, so median value, I can find something like 5, okay, 2, 4, and some value out from here that is 2. So 5 is cancel out. Then 4 plus 2, that is 6. That will be canceling out. Then we are left with 10. Okay, so the median will be 10. So I can see the median value will be over here. So that will be the median value that will be coming out to be 10. So in this particular case, the case of left skewed data, I can see my mean value is smaller than the median value. Okay, so we need to learn this concept also. So you can note out these two concepts. Like for right skewed data, we have mean bigger than median, and for left skewed data, we have mean less than median. Okay, so that was the basic concept regarding the skewness, the mean, median, and the concept like how the skewness is associated with our mean and median. Okay, now let's go ahead and just come to health club again. Okay, so in the previous example, we have seen like, okay, there was a guy, I don't remember the name, I guess Clive. He visited our health club. Okay, so let's come back to the health club. So we have various kind of classes for health club, and let's assume that this guy, I don't know the name of this guy, this can be anyone. So this guy came to our club and say, okay, the swimming class you have for teenagers sounds cool. Okay, so technically, if I go for my swimming classes and I have some data. Okay, the median age for the swimming class is coming out to be 17. Okay, median that is coming out to be 17, and assume that the mean is also 17. So from the mean and from the median perspective, I can say, okay, if the age is 17 or something like 16, 15, 17, 18, 19, I can say, okay, swimming classes are better fit. Okay, so from the data available to me, I just assign swimming classes to this guy. Okay, like the mean age for the swimming classes is coming out to be 17, or the median age is coming out to be 17. So this guy say, okay, that means to say like swimming class, that is a perfect fit for me. Like I can find the people from my age that are teenagers can be there, so that I can make up some new friends. Okay, so I assigned some classes of swimming classes to this guy. Okay, now what happened? Now the problem is that the swimming classes allow parents to teach their young kids or children how to swim. Okay, so there might be the issue, like in the swimming classes, there are some children. Okay, these are the children, and there can be some parents. Okay, like these people are teaching their own kids or own children, like how to swim. So we have various kind of data in this particular case, like the data for children, the data for parents, and we are finding the mean and the median for this complete data. Okay, and that is coming out to be like 17. Okay, now there are like only children or the parents. So children are might be like from the age of like can say 2 to say 9. Okay, and parents are from the age of like 30 to 40. Just assume. Okay, in this particular case, I have assigned the classes to this guy as the swimming classes, but he ended up in this group. Like, okay, either there are only the childrens or the parents. Like he doesn't fit well. So technically, okay, this security guard at the club or at the swimming pool, he came up to this guy, okay, where's your baby? Like you are not a kid. Oh, so technically you must be parent. So you must have some kids. So this guy is like, what the heck? I again ended up in some wrong class. Okay, now let's see how the problem assigned or how the problem arise in this particular case. Okay, so let's take up this particular example in some form of data terms. Frequency magnet. That means to say we have like we have some frequency magnet. That means to say like we have some age group like 1, 2, and 3, and we have some age group like 31, 32, 33. So roughly I can see that these are the ages for parents and these are the ages for children. Okay, and we have some follow-on of frequencies like okay, this frequency is 3, this frequency is 2, this frequency is 2, but I don't know this will go over here or something over here or something over here. I don't know the exact position of these frequencies. Now the given thing is that we have like 9 children. Okay, this is given, and we know for the data for this particular guy that the mean and the median, that is something like 17. Okay, in that case I can find like what will the frequency of age group 2. So I know there are total 9 children. That means to say 3 plus 2, that equal to 5. So 9 minus 5, that will be 4. So the frequency for this will be 4. Okay, I assigned the value this to this particular case. Now let's find out like what will be the frequency for this point and for this point. Okay, if I assign the frequency to be A and assign the frequency to be B over here, then I know the mean value is coming out to be like 17. Okay, so mean value mean to say the summation fi xi divided by summation fi. Okay, so that will be coming out to be something like we can calculate it to be like 3 plus 2 into 4 plus 3 into 2 plus 31 into 2 plus 32 into A plus 33 into B divided by total frequency. Okay, so the total frequency is something like 3 plus 3 plus 4, 3, 3, 6, 9, 10, 11, 12, 13, 14, 14 plus 4, that is 18. Okay, so that will be coming out to be like 17. We know the data, like the formula for mean. So from here we can calculate, we can get equation something like, okay, so the equation will be coming out to be like 32A plus 33B, that will be equal to 227. Okay, and we need to assign the frequency A and B some particular number, say that can be 3 or 4. Okay, from here we can observe that the final summation of these two terms, that is coming out to be some odd number. Okay, now the major or can say the basic concept from mathematics states that sum of even plus even, that will be even number. Okay, sum of even plus odd, that will be odd, and sum of odd plus odd, that will also be even. So this is the only case that we have. Okay, so if I take up this case, that means to say either this number is even and this number is odd, or this number is odd and this number is even. And we can clearly see that this is a multiple of 2. That means to say 2 into some number that is coming out to be 32. Okay, so this some number is the 16. Okay, so I can see that this number is an even number. So if I multiply any number by some even number, this complete number will be an even number, and be this number will be like odd. Okay, so only this case is possible. Like 32a, that will be some even number, and 32b, that will be some odd number. And we have a and b to be from like 3 comma 4. So if I take a 4 value over here, this term will be coming out to be even. That is not a possible case. That means to say our b must be equal to 3. This implies our a that must be equal to 4. Okay, so now I have assigned the values to this particular table. So I can see the frequency for 32 age group, that will be coming out to be A, and I know A equal to 4. Okay. And for 33, I can find an like frequency that is coming out to be 3. Okay. So I have completed the table. So now let's look up on some graphical format for this particular table. So this is the graph. You can see the histogram. So I can see like we have some age group like 1 to 2, 2 to 3, 3 to 4. Okay, and we don't have some data from this particular range, that is 4 to 31. Then we have some data for 31 to 32, 32 to 33, 32 to 34. Okay, so if the histogram is coming out to be like this, you can completely draw the histogram. Okay, I have made some frequencies and some age groups. Okay, so technically from this particular graph, I can see like this is one cluster. Okay, and this is another cluster. Okay, so there might be some mean for this cluster, like mean 2, and we have some mean for this cluster, mean 1. So technically these both means will make the total mean, or can say the complete mean for this complete data, that must be in between these two values. So the mean and median are something over here. But as we can see in this particular data, either we have children or we can have parents. So the children data is coming out from like 1 to 4, and for the parent data that is coming out to be like 31 to 34. But the mean and median that are coming out to be 17, that is absurd in this particular case. Okay, we can see that thing. Like this is absurd. There is no person, neither a child that is of age 17, nor a parent with an age of 17. So technically, this is a rise of some error. Okay, that's why there is some issue with that guy that visited our swimming club, or can say the swimming classes. So this is a problem that we need to deal with. Okay, so we can see like three cases in this particular case. Like we can calculate the median to be like 17 in this particular case. Okay, but what if I add more values to the data? If I add up like, okay, if I go to this particular case, the only data that we have, in that case, we can see, okay, we have values over here, we have values over here, and the central value will be there. So technically the median, that will be equal to 3 plus 31 divided by 2. Okay, that is coming out to be like 17. Okay, but what if I add, this is like case 1, and if I go for case 2, in that case, I just added another term, okay, one more entry, that is age 3. In that case, I can see like, okay, these are the half values and these are the half values. So the 3 is the median. But in this case, we can see there is a problem. Like we have these two data groups, one for the children and one for the parents. So the median value is stating that the most accurate value, the most representative value for the data, that is 3. But I know there are parents also. So technically this 3 is again some absurd value. Okay, in a similar format, if make I make up some another entry for some parent, like this is the entry, like 31. In that case, the median will be 31. But again, this is arise to some absurd meaning, like not a representative method, as we have like two different kind of data in this particular data. We have two different clusters, one for the parents and one for the children. So that will be coming out to be some error, that is some absurd, or can say some the meaningless, something meaningless median, or the data points that are in the data, they are not completely defined by our central value, that is median. Okay, so these are the particular three cases. Now the same question on this particular case, like if I go for asking the particular cases regarding the same problem, Like we have the frequency table, the age and the frequency. So why do you think the mean and median both failed for this data? Like we have mean and median that is coming out to be 17. So why do you think? Give it a thought. Can you think about the same thing? Like why our mean and median failed in this particular case? Okay, so let's come up to this problem. So if I go for our mean value, that is coming out to be 17, and we can see like there is no one with an age of 17, either they are children or the parents. So the mean value is coming out to be absurd or can say meaningless. It is misleading. Okay, if I go for the median value, that is coming out to be like 17, and it can fluctuate. Okay, technically in the initial understanding of median, I told that I can make many medians. Like if this is a central value and this is the middle value, these both two are the middle values. In that case, every point in between these points is a median. So technically, median is fluctuating. So that means to say it is not an appropriate fit. Okay. Now the problem two states that if you had to pick one age to represent the class, what would it be? Okay. So we have the complete data, and this data is for like kids. If I say kids, and the data is for like parents. Okay, now they are asking to pick up only one age. Okay, so either I can pick an age that is appropriate for the kids. Okay, so the age one, or if I say the age two. Okay, in that case, but I need to choose only one. I need to take up only one age. So if either I can take age one or either I can take age two. So in that case, this age one is not representing the data for parents. In a similar format, this age two is not representing the data points for kids. So again, this is not a good option. It is not a good option. Okay. Now they are asking now, what if you could pick two ages? Okay. Now I can think about this thing. Okay. So what if you could pick two ages instead? Okay. In this case, one is now they are saying, okay, if the data can be represented or representative by using two particular values, or can say two particular ages. So this can be okay. Yes, this is possible. Okay, but how does this thing possible? Like we have cluster one and we have cluster two. Okay, like this is for the kids and this is for the parents. Now I can pick like one value from here and one value from here, so that this data is defined by this particular value, say A1, and this data is defined by this value that is A2. Okay, then how can I choose that? So the data for kids that is coming out to be like 1, 2, 3. So I can choose a value 2. Okay, so A1 equal to 2. In a similar format, I can choose a value like A2 that equal to 32. Okay, and how did we choose these two particular values? We find 2. Now this 2 is coming out to be the maximum number of times. Like 2 is appearing for 4 times and 1 is appearing for 1 time, 3 is appearing for 2 times. So I choose a value that is having maximum frequency. Okay, so I can say this is the most appearing value. And this most appearing value in the age group data that is for the kids, this will be a perfect representation for the data that is for kids. In a similar format, I can define the A2 that is coming out to be like 32. Again, the 32 is the data point that is coming from the maximum number of times, like 4. 4 is maximum among 2, 4, and 3. That means to say it is also a most appearing value. So I can represent the data for parents by some particular value that is 32. Now this arrives to the concept of mode. So this is the concept of mode. And we will continue with this concept of mode in our upcoming lecture. So in this particular video, we studied about median. We calculated like how we can understand the meaning of median, how can we calculate the median, how can these things can be combined, how and where this median fails to give us appropriate results. Okay, so I hope you got the concept of median, and we will continue with mode in our upcoming lecture. Thank you.